Hi, welcome to the AFM laboratory. Today I will show you how we prepare the AFM experiment so that everything is ready when you log into the computer. Here you see the system. The computer is already switched on. The AFM is here inside this glove box. You see the main body of the AFM. That's where we will do the measurement. You see here, this is the anti-vibration table that separates the AFM from the vibrations of the building. And this is the control electronics. As a first step, I switch on the instruments. And I log into the computer. The anti-vibration table has to be activated. Here you see on the screen the vibrations being present in the building. For example, when I walk around, you see the vibrations clearly. Now to isolate, I activate the feedback. And now you see how the vibrations flatten. Takes some time. And then I can still walk around and it's all damped, so that the measurements are more stable. Okay, now the next thing is to activate the software. So the software is the Smart Scan software. And here you see how it starts up and hopefully connect well to the instrument after this 6-week break. Let's see if there are some errors or if we can connect. Looks well. Welcome back from holiday, AFM. Here we are. So the instrument is now connected. Next is that we have to calibrate, insert the probe and insert the sample. All right, here we go. So you see that the software is running. The AFM is switched on, and we now have to put the sample and align the beam and all this kind of things. So in the main body you have the optical microscope. That's all this big one here. You can see here the objective. And then you have here the probe hand. And below here you can see the sample holder that's with a magnet where we can attach our sample. Now in order to mount the probe, we have to remove the probe hand. For that, here is a switch that I will use to switch off the beam. And then you have to unlock the head. These are typically operations that you would do with 2 hands, but let me say I'm used to it that I think with 1 hand in order to show it everything, to show it to you would be fine. So I do a slight push and the whole thing can now slide out of the... Okay, so this is the head of the AFM, the head module. It contains a lot of elements. Let me just put it down and then I will show you in more detail. So here we have a special holder for it. I put it down and then we can have a look. Okay, that's how it looks from close by. You'll find everything also in the documentation. So what we have here, imagine now it's turn around, right? When it's doing the measurement, the tip of the AFM. So here we have the probe hand. That's where we actually mount our probe. You see the probe end is connected with 3 electrical wires. One is red. That's to connect the bimorphs. That's a piezo oscillator. Then we have the black cable, which is the ground, and we have a gray cable, which connects electrically the AFM tip for doing, for example, electrostatic or the conducting AFM measurements. All right. Next, we see a couple of mirrors. We see here one big mirror, and then we see below a smaller mirror. Now, and then we see here below the big mirror, maybe we enter a little bit, you might see here a small opening. That's where the laser diode is positioned. So the laser diode will shoot on the small steering mirror. From there the beam will be reflected and we will set it onto the cantilever, being here. From the cantilever it will again be reflected onto this large mirror, and from the large mirror it enters into the PSPD, which is the black window that you can see here. Okay, that's the PSPD. All right, so what I have to do now is I have to mount a tip. Let me just show it for you with a U-tip, because doing it one-handed is a bit more difficult. So tips are stored in these boxes. Typically a box contains 10 tips. So let me just take one of them. You see this is of course more than just a tip, so it's a tip holder. That's the metallic part that I'm taking with the tweezers. And then on this metallic part you see attached, sorry, now it's getting out of zoom. You see attached the piece of silicon, that's the darker one. And at the end of the piece of silicon you might recognize some small stripe. And that's the etching mask where you start to have the cantilever. Of course the cantilever you can't see it, and at the end of the cantilever you will see the tip. Okay, now I'm putting the AFM tip into place. So I have it taken in my fingers. I can hold it easily. Of course I should not get close to the chip because that would destroy it. And then I just move it here on top, and there is a magnet that attaches the tip to the holder. Okay, some arrangement that it's precise where it should be. All right, now it is positioned. Okay, hope you can see it. All right, and we are ready. Okay, good, I have mounted the tip. So now I have to put the probe pen back into position for the movie quality. All right, I'm putting it back. Okay, it slides in, and then we're done. Okay, good. The probe pen is mounted with a tip. Now I take the sample. Here I can just take a simple piece of ITO, for example. So it's mounted to a so-called AFM sample holder. That's a piece of metal that you see. Okay. So ITO is this transparent glass that you characterize in another experiment. Here I have mounted onto the AFM sample holder, and I put it to the magnetic chuck. All right, done. Next step, we have to align our optical detection system. If I now go to the program, I see the optical microscope window, and in the microscope I have here, this is a small cantilever. You see this is a length scale of 100 microns, so it's the length of the cantilever is 100 microns. At the very end you have the tip, and here you have the chip. What I now have to do, I have to put this tip into the center of the microscope and direct the beam onto it. All right, to do so, I use the optical focus stage and focus first of all on the cantilever. Here it's a bit older cantilever, it looks a bit scattered. Okay, good. Now it's focused. Next I have to align the beam. And in this setup we always know that the beam is right here. You see that it produces some kind of reflection artifacts from the underlying surface, but the main spot of the beam is here in the center. And I can now rotate here the screws of the steering mirror, in order to move it a little bit to the right. So here I'm starting to rotate, and then I look here at the screen if I see something happening, and there it is. So the beam is now on the cantilever. Next, I use the micro screws from the optical microscope in order to center. Okay, good. So now it's centered, and I still improve a bit on the position of the beam. Okay. Okay, that looks pretty maximized. Next, I have to direct the beam into the PSPD. And for doing this, I look at only at the intensity values and try to find a spot where the intensity maximizes. Okay, here we are aligned. Good, so now I have to center it. Okay, and the beam is centered. This is a pretty old AFM tip. When you do the measurement, I will give you a better one. You see that it is old because you see that the intensity of the reflected beam is below 1 volt, and that is not sufficient to do the measurement. But the alignment process and everything that I've shown you so far is exactly as I will do it when you do the experiment next week. Okay, so you see this is now a nicer tip. So you see the cantilever now much clearer. You see the reflection of the beam. This is a PSPD signal. You see now that it's above 5 volts, so that's perfect. It's centered and everything is set up. So what I do now, I approach the AFM to the surface. So this is the first phase of the approach, where I still look with my eyes how close I am to the sample. So this is here the zeta stage, and I can move it. So I go downwards to move as fast as possible, and I keep the mouse button touched, and when I do so, you see here the AFM approaches to the sample, right? Okay, you see here also the sound of the motor, and I watch it until I am roughly okay, we are now pretty close to the sample surface, roughly 1 millimeter, and we have to get closer. To do so, we go to the software, and this is something that with a good network connection you could do already just online, but it requires a fast connection. So I will show you how it works. What I do, I switch off the beam now, and I turn off the light from the microscope. I expand the visual view so I can nicely see the cantilever of the AFM, right? So this is our cantilever, and I'm close to the surface, but still here I do not see the surface at all. So what I can do, I can move the focus states further downwards. Okay, so I'm moving it downwards now, and I move it downwards until I see in the microscope the surface. Of course, the cantilever gets out of focus. I can move a bit faster also. And typically there is some dirt on the surface so that I can recognize it. And here you see the ITO is of course transparent, so it's a bit more difficult to see, but you can see here the dust particles, right? And you see already that the scanner is already warming up, so it's moving left, right, left, right. Okay. And now here I see the value of the focus stage, which is roughly 10,000. So at the moment I'm at position 10,000 micrometers. I have to remember this value and I move upwards until I have again the focus stage set on the cantilever. All right. And now I look again at this number and I am at 11,000. So my cantilever is 1,000 micrometers, that is 1 millimeter, precisely 1 millimeter above the surface. So what I can do, I switch on again the beam and I move downwards with the whole stage to approach the cantilever closer to the surface. Now I know that I'm 1,000 micrometers close to the surface, so I move downwards 800 micrometers. That is 4 steps of 200 micrometers. So 1, 2, 3, 4. And now I should be on the order of 200 micrometers close to the surface. I can okay, good. So I can switch off again the beam and check that. So I go downwards until I see something of the surface. Okay. And this is now a distance where you can see it focused the surface and a little bit unfocused on top there is a cantilever. At that position you could now decide where you want to measure. With this one here, resize, so I can now move around. I hope that for that the network connection is fast enough. So you choose a position where you measure, that's roughly where the white cross is. And then you can switch on the beam and start with your experiment.